to Natural Language Processing. It will be handled by Dr. V. Uma, Assistant Professor, Pondicherry University. Now I request Mr. Manikandan J, Assistant Professor CSE, to introduce our resource person.
I feel glad in introducing the speaker, Dr. V. Uma, Assistant Professor, Department of Computer Science, Pondicherry University, to the gathering. Dr. V. Uma, presently working as an assistant professor in the Department of Computer Science, Pondicherry University. She has received her MTech degree and PhD degree in computer science from the same university. She is a recipient of Pondicherry University Gold Medalist for MTech degree. She have more than 14 years of teaching experience at postgraduate level. Her research interest includes machine learning, knowledge representation, and sentimental analysis. She has authored and co-authored more than 40 peer-reviewed journal publications. She also authored books on Python and C++. She has received two Best Paper Awards in international conferences. I thank her for providing her gracious presence to join us today. Now I request Dr. V. Uma to take over the session. Over to you, ma'am.
Thank you, Manikandan, for that nice introduction. So, can you stop the presentation, please?
Yes, ma'am. Yes.
Okay. So now I will share my screen, and before that I would like to thank the organizers for inviting me to deliver a lecture on the topic that I'm really fond of. So first I should thank for the organizers for doing this, because this is a research area which I'm really interested in, my area of specialization, and so I think I will be delivering the lecture in a fulfilling manner. And so I request the participants first to interact and ask your doubts then and there, because this is going to be just 1 hour session, and covering the entire details regarding sequence modeling is not possible. But still I will give you an idea about what is sequence modeling, how you can do it, why you should go for it, and a simple example that I will take and show you, like how you can do, as this thing is related to sentiment analysis. So again'll show you like how to do sentiment analysis. I think the previous session was on sentiment analysis and health informatics, and so any data that you take, you want to do sentiment analysis, and how will you do it using the sequence modeling is going to be my session. And so I think it is relevant to the previous session, and so please interact and ask your doubts then and there, so that I'll also be interested in giving more details. Okay. So with this introduction, so I'll just share my PPT. Can you see my screen? Is it visible?
Yes, ma'am. It is.
Okay. So this is going to be my topic. Now I want somebody to explain this topic. What do you understand from this topic? What is sequence? We'll start with that. What is sequence? Anybody?
Uh, Sequence is a list of characters.
Okay. Any example that you give, ma'am?
Like a sentence, ma'am. For example, deep learning. So that is also a sequence. We can tell that the deep learning provides a comparatively better result than the machine learning. So this is also a sequence.
So sequence is nothing but that has some order, as Madam told, like Madam Jaipuri told. So sequence is something that has some order. Okay, so you can see my right part of my screen, that you see some sequence, right? And this sequence will have some order. That order may be the time in which it is arriving, or that maybe even if I put this, I'm sorry. Okay. So when I write a sequence, we all know this, right? What is this sequence about? 2, 6, 4, 6, 8, 10. It is a set of even numbers, right? So it is also a sequence. It has some order in it. And so this is called a sequence. So anything that has an order, you can say that it is having a sequence. That order may be a time series, or that may be a set of characters, as Madam told, or set of words that has some order. The way the speech that I'm giving, it has some order. One word comes after the other. So there is some order in whatever I deliver. The audio signal that you hear has some order. The activity I'm doing, the video frame that you are looking upon has some order, right? So whenever there is an order, you call that as a sequence. So how are we going to model that sequence for natural language processing? What do you think about natural language processing? What is natural language processing? Anybody? You would have studied this already, right? What is NLP? NLP has so many things. Okay, let me tell. So you have a language, right? And it has some characteristics, and you're going to process those characteristics, and you're going to do something with them, right? So you may have some, say, the words that I am delivering, it's a natural language, right? I have to process that words, and I have to make some decision, like I want to find out what I will speak in future, or I want to generate a sequence on my own. So anything that you do with your natural language, you call that as natural language processing. So what my lecture is going to do is that I'm going to tell how to model your natural language sequences so that you can do some processing on it, right? It may be a prediction, it may be a regression, it may be under prediction, it may be a classification task or a regression task. So this is what is going to be seen in this lecture. I hope I'm clear what I'm going to deal with. So before getting into always a very higher level of topics, but first we should understand where we are, right? What we are talking about. Like as Jaykuri madam told, like she was talking about the word deep learning, but where it stands, where it is actually, why do we want to talk about deep learning? So this is the first thing that comes in our mind, right? So don't think that again madam is talking about AI, machine learning, deep learning, all this we all know, but I'm coming to the actual point. So please bear with me for 2-3 minutes. So what is artificial intelligence? I'm audible, right? Manikandan, am I audible? Is there any issue in my network? Or any of the participant, you can answer me. Is there any issue in the audio?
No, ma'am. You are audible, ma'am.
Okay, thank you. Okay, so what is artificial intelligence and what is deep learning? Anything that you can tell me. What is intelligence first? What is intelligence? When do you say there is intelligence? Okay, so I'll put it in this word. What is intelligence? Because these are daily terms that we use. I always use the term artificial intelligence, but what is intelligence? The ability to comprehend whatever I see, whatever I listen, I should be able to comprehend. I should be able to understand what is happening. Okay, and the ability to act accordingly. When I understand something, I'll be able to act accordingly, right? And how do I act? I reason out, I learn, I do something, right? How do I act? I see something, I see a picture of a person, and immediately I understand that that person is Manikandan, and then immediately I act and I say that hello Manikandan. So this action, how do? I do reasoning or I do learning. Right. So here comes the terms learning. So when we talk about learning, immediately they coined the term machine learning. The machine has to learn. Why it has to learn? Because every time its performance should improve. Right. First time when I see Manikandan, I say hi. But next time when I see Manikandan, I understand that he is coming from Rajeshwar Engineering College, and he is my former student. And I remember, I recollect that he is my former student, and immediately I react in a different way. So what is happening? The performance or the interaction improves with respect to your experience for the same task. Please understand the word for the same task. Right. First time I'm doing a task, I'm doing it in a very normal way. But next time I'm gaining some experience and my performance improves. So this is where you call it as learning. Right. So this is the objective of machine learning. My performance should improve with experience. And in this, what they thought was like my performance should improve, right? But it should improve to the level of human intelligence. Right, the machine should behave very similar to human intelligence. So what they thought was, with respect to machine learning, if I can make it learn deeply, then the performance will improve even more better compared to your machine learning approaches. So this is how it got evolved, right? And doing this, so they wanted to mimic the human brain in deep learning approaches. So our human brain works like this, like it has something called a cell in which you will be having a nucleus, and this the information from one neuron will come to this through the dendrites, and it will process the information, and based on the information it gets, it triggers the electrical impulses, and this impulse will be traveling through the axons, and it will be connected to another neuron, and this gets transmitted from one neuron to another. So slowly the signal is being transmitted based on the activation that is happening. Right. So if say I am touching a hot object, right, immediately my hand, the reflex is that I take away my hand from that hot object, because there is some impulse that tells that that is being triggered, and that information is passed to the neurons, the next level of neurons, and immediately I take my hand away from it. So this activation is happening, and only then our human brain is passing the information from one neuron to another. And similarly, what they did was they wanted to create something called neural network. The same principle. I have the signals here, right? And based on the signal, some activation will happen so that I get the desired output. So when I touch the hot object, what should I do? I should take away from take my hand away from it, right? Similarly, when I give some inputs based on the activation, I will get the desired output, and until I get the desired output, I'll be repeating the same thing. I'll be having one set of neurons, that information will be passed to the next set of neurons, and similarly it gets traversed, and till you get the desired output, you will have several layers of neurons and stacked stacked to one another, right? And you proceed till you get the desired level of output. Okay, and this is what I was talking about, right? So you have one set of neurons, and there will be another set of neurons, and I'll be giving some inputs to this system, right? So it, say for instance, I'm going to classify that the given symptoms fall under dengue or malaria, right? So the inputs will be the symptoms that I have, like I may have skin rashes, fever, cold and cough, headache, vomiting. So these inputs will be given, and this no neurons will, I take the inputs, like do some operations on it, like it'll do a summation of the thing, and it'll do some activation based on the symptoms, right? It'll activate, it'll trigger the neuron, and it'll send the output to the next level of neuron, and so that finally when it goes to the output, you will check whether we get the desired output. In case if I'm not getting the desired output, the error should be propagated back through the neurons, and again the system will be trained so that till I get the desired output, I will be doing the same thing. How will I know the desired output? Because we are training the system with the known outputs, right? So my training system will go like this: I will have skin rash, I don't have fever, I don't have fever, I have cough, I don't have headache, I don't have headache, I have vomiting. Please don't relate it with dengue or malaria, because I'm not sure about what all features correspond to dengue. But in my training data, I will have that value here. Okay, so I will train the neurons again and again so that till I get for the given input, if I get dengue, then my training is perfect. For the input, if I'm getting malaria, then the training is not sufficient. So what should I do? I should again train the system. I should convey this information that the output is not correct. So I back propagate the errors, and so again I retrain and adjust the weights. Here I come here. You cannot change the inputs. The inputs are the same. I have skin rash, I don't have fever, I have cough, I don't have headache, I have vomiting, the features are same. But the output should change. Then how will I change the output? Only by adjusting the weights. Right. So between one neuron to another neuron, one layer to another layer, I have certain weights. Right. So these weights are to be changed so that when actually what you are doing, you are multiplying the weights with your input, and that information is passed to the neuron. Right. And you should also understand that the features should be a numerical value. So there should be a way in which you you convert your features to your numerical value and multiply that with some weight matrices, and that information should be passed to the neuron. Okay, and this information will be passed like if it passes some threshold, then that neuron will trigger the output, and that will be passed to the next neuron. If it is not having that desired threshold, then the neuron will not be activated, and the output will be something like it doesn't give you the desired thing, because it doesn't trigger the neuron. The heat that I'm touching, right, it is not sufficient, so my hand need not be taken, it is just warm, I need not take it. But once it crosses the threshold, the thing will be triggered, the activation function will trigger, and you will get some output. Right. So this is normally happening. Why I'm giving more information on this is relevant to your RNN also. So RNN is not something entirely different from your normal neural network. It is recurrent neural network. So you should understand what is happening inside your neural network. Okay, is it clear? You are clear with your basics of neural network, because I cannot start from what is machine learning, because my given topic is neural networks, recurrent neural networks, and so in that way I'm just giving some abstract idea about neural network. But feel free to ask your doubts. If you have any doubts, you can ask me. You can stop me here. Any doubts? Are you clear?
Excuse me, ma'am. There is some unnecessary extra noise from your side, ma'am.
Oh, okay. Maybe that I have switched on my fan. Okay, now is it fine?
Okay, ma'am. Fine, ma'am.
Okay. Okay. So why should we go in for deep learning? Please understand that. Right. So machine learning has it is finding some decision boundary. You all know that. I think all of you must be having an idea about what is happening inside your machine learning and deep learning. Right. I am trying to classify, or I am trying to do regression. Right. Say for instance, if I'm having a set of points, these points belong to the like male students inside. Say this may be your height and weight of students. Right. So I say I'm calculating the BMI. I want to classify whether a set of students are have overweighted, or they are underweight students. So what I do is I plot the height and weight of the students. Right. So I'm just plotting it. Now I want to separate it. Like if I say that their height and weight values are high, right? So this part of these students are having a greater BMI, and the students on the left hand side are having proper weight. They are not overweight. They are having a proper BMI. So I want to classify. Right. So this, you can see that this classification is more or less linear, right? The points clearly show that these two, the line, the decision boundary that I'm finding, the green line, is more or less linear. It's not too non-linear. Right. So in this case, I can go in for machine learning approaches. So there's no nothing like I don't require any complex deep learning approaches for doing it. But when I want a classification here for this one, right hand side, say if I have a thing like I want to find out whether this particular person has dengue or malaria, and I'm plotting his values like fever. Please remember that even though you have a value called fever, it has to be converted into a numerical value. And again, skin rash, and just plotting it, I find that the dengue people are in red and the malaria people are having blue points or represented using blue points. Now you can see that the decision boundary, right? The decision boundary, I have to find a decision boundary, which will be like, it will be like a circular one, which is non-linear, right? It is non-linear decision boundary that I'm going to find. So here in this case, more than your machine learning approaches, your deep learning approaches are going to contribute more. And that is where we go in for neural network based approaches. Is that clear, all of you? So this is one hack why we go in for deep learning approaches. And deep learning is not very different. See, I'll tell you the difference of machine learning and deep learning with respect to your neural network itself. So if I have the input, all neural networks are not deep learning approaches. Please understand that. If you have a hidden layer and you have your output layer, so how many layers are there here? This is your input layer. This is one hidden layer and one output layer. So how many layers are there in this neural network? This is an artificial neural network. How many layers are there?
3, ma'am.
Yes, but please avoid the input layer. Input layer is not your thing. So this is called a two-layer neural network. Two-layer neural network. So if you have more than two layers, then you can put it under a deep learning approach. But normally, even 3 layers, they don't take it as neural network because that level of complexity we have reached. So we build more, even 100 layers of neural network. But if you have a normally, this is a machine learning approach. This is not a deep learning approach. Why do I say this? Right. So one thing that you should understand is that the machine learning approaches requires features for your classification, and these features are to be fed by a human being. Right. So if I give a car picture, your machine learning algorithms, your two-layer neural network will not find out whether it is a car or a truck because it cannot learn the features on its own using one hidden layer. Okay, so it has to have many number of layers, then only it can learn the features. Say the first layer of neural network will learn that there are 4 wheels. I'm literally saying, right? It will learn that there are 4 wheels in your car. The second layer of neural network will learn that there are 4 doors in a car. And the third layer of neural network will tell that there will be a bonnet in front of the car. And the fourth layer of the neural network will say that there will be a dicky at the back end of the car. So the layers only will learn the features on their own. And this cannot happen if you have very less hidden layers in your neural network. So as your neural network increases the number of layers, you call that as a deep learning neural network. Is that clear, all of you? You understand what is the difference between machine learning and deep learning? Right. And so obviously you understand that the data should be more. If I give only 10 pictures of your car, the algorithm cannot generalize. I give only 10 pictures of a car. Will the algorithm learn the features on its own? Will it learn that the car has 4 windows, 4 doors, and for a dicky and bonnet? Because it doesn't know. Right. When you give 100 pictures of your car, then the algorithm will learn on its own. So as the amount of data increases, your deep learning algorithms will perform well. But if you have very less amount of data, then obviously you have to hand code the features and then you have to use your machine learning algorithms. So that is why when the data is less, then you will see that your deep learning algorithms are not performing well because it cannot learn the features on its own. So this is an important thing that you should understand. So don't always think that deep learning algorithms will perform well. Please give me a second. I'll switch on my AC at least. Okay. And also, because of this thing, you can see that it performs an end-to-end solution, gives you an end-to-end solution. Because by giving the picture, this picture I'm giving to a machine learning network, first it has to classify whether it is like, it has to first detect the objects. What are all the objects there first? And then only you can go for the classification, whether this object is going to be a car, truck, or it is going to be a traffic signal or traffic light. All this has to be done with multiple levels of classification. But in your deep learning approaches, you can go in for an end-to-end solution. You can parallelly detect the objects, and you can also parallelly recognize the object, whether it is a car or a truck, and you can thereby produce a solution for the problem. Right, so these are the various neural networks that you have. You have these are not comprehensive thing, but you have more neural networks, and these are some neural networks that are being widely used. So you can see that as the number of layers increase, only you call them as deep learning approaches. Okay. So what is deep learning, right? So here you can see that more neurons, right, and more complex ways of connecting layers, and you can have explosion. You need more computing power, and you have automatic feature extraction. Okay. Okay. Now I'll come to an interesting thing. You would have heard of this term like why we require deep learning. One other important hack, right? Why do we require a deep learning approach? Why can't we go in for machine learning approaches? Right. So in AI, there are two things that you should remember. One thing is that you can perform learning, detective learning, and you can perform inductive learning. Okay. So what is deductive learning and what is inductive learning? Anybody? Anybody who knows this? What is deductive learning and what is inductive learning? Okay, I'll give you an example, right? So I'll put it in this way. Okay, Socrates, you would have heard this, right? Socrates is a man, and Socrates is mortal. Okay, and I give another term called all men are mortal. All men are mortal. Okay, so now we'll see how deductive reasoning works. So if I know the fact, okay, all men are mortal, please make a note of it, all men are mortal. Socrates is a man, what will you detect?
Socrates is a mortal.
Socrates is mortal. So this is called deductive reasoning. What you are doing, you are deducing from general statement, you are going for a specific statement. What is that specific statement? Socrates is mortal. What is the general statement? All men are mortal. So when you are moving on from general values to specialized things, that is called deductive learning. I learned that, right, Socrates is mortal. Where did I learn from? I learned from the general concept. Now we'll go in for the other way. Socrates is a man, Socrates is mortal. Now I am learning that all men are mortal. That is called inductive learning. I know Socrates is a man, Socrates is a mortal, right? And then I'm generalizing it to all men are mortal. So this is called inductive reasoning. So till 1990s and 2000s, we were using only deductive learning. What is the general fact given? I will learn the specific fact. Right, but when came in for with respect to machine learning and deep learning, we went in for this inductive learning. So the idea behind all these deep learning algorithms is that we want to have inductive learning. We want to generalize things. That is where the complexity comes. Okay, I will tell you another interesting thing also. What do you mean by strong AI and what is weak AI? Anybody? What is strong AI and what is weak AI? One second. Anybody, can you tell me? Okay, now I'll give you an example, right? I'm having a cat. Okay, I'm having a cat robot, right? And I have trained the cat robot with respect to say a walking, running, and like making some noise. I have trained the cat with all these activities. Now I'm throwing the cat robot inside water. What will happen? I have not trained the cat with respect to swimming. Okay, I have trained only with respect to running, walking, and making some noise or some actions other than swimming. What will happen if I throw the cat inside water? Will it swim? No. Right, but if I have a real cat, I put it in that water, it has some ability, it has some cognitive ability that I have been thrown inside the water. I'll try at least to swim. If not at least to the fullest extent, I'll try something so that I'll get away with it. Okay, so I want to build machines like human beings. If I can do that, then I have achieved strong AI. But the fact is that till now we have not reached that level. We are still in the part of weak AI. So whatever we are doing, whatever sequence modeling we are trying to do, whatever NLP pros we are trying to do, it is still under weak AI. Even your autonomous car driving, I am writing some program and the algorithm I am building will work with respect to the training I have done. It doesn't have cognitive ability on its own. If entirely new environment comes, then it will crash. But if a human being goes inside an entirely new environment, it can do some activity which a machine cannot do. So once you reach that point, you call that you have built a strong AI system. Till now, we have not reached that level. So these are all some attempts that we are doing to build a strong AI system, and we are going upon it, right? Instead of the machine hand coding, the person, human being hand coding the features, what did they try? They try to make some models that can learn on its own the features. So they're trying to build some strong AI systems, but still we have to proceed. We have to go. This is where we are heading towards. Right. So in this, we are getting into deep learning, and we see that we have supervised, unsupervised networks like autoencoders, deep belief networks, GANs, convolutional neural network, recurrent neural network, recursive neural networks. So all these have been developed to achieve some artificial intelligence or machine learning, and we are moving towards strong AI, but still we have not achieved it. Okay, so what is the internal classification among these deep learning architectures? When you want to generate images or audio or text, you go in for GANs, variational autoencoders, or recurrent neural networks. If you want to model images, you want to do some face recognition, you want to have object detection, you want to do some face verification, then you can go in for convolutional neural networks or deep belief networks. If you want to model sequence data, obviously the choice is going to be recurrent neural networks or LSTM, which is a variant of your recurrent neural network. Okay. So these are the different types of neural networks. Why madam is putting a deep artificial neural network? Already I gave you the hint that artificial neural network, when you increase the number of layers, it's again a deep learning neural network, right? Convolutional neural network and recurrent. So these are going to be our prime thing. So why I'm talking about this is like everywhere when you try to process some text or images or sequences, these two networks come there. So why can't we use neural networks for sequence data? Why can't we use convolutional neural networks for sequence data? Why should I use recurrent neural network for sequence data? So this is the point that we have. So as I told you, like you will be getting inputs, you're doing some operations, you're doing some activation, and you're getting some output. This is artificial neural network. But one thing that you should remember is the input size is fixed. Please remember this. The input size is fixed. If I have 5 features, then those 5 features should be there for all the records. I have data for 100 persons. I want to give it to a neural network. I have 5 features for identifying dengue or malaria. Then all the 1,000 people's 5 features should have values, or you can fill it with null values, but the input size is fixed. You should give fixed size input to your artificial neural network. Please remember that. Okay, so the other drawback is that why can't I use artificial neural network for sequence data? The other problem is the vanishing or exploding gradient problem. Right, as you increase the number of layers in your artificial neural network, the information about the previous word will be lost. Say, for instance, I'm giving that Uma is handling a lecture. Okay, handling a lecture. She will finish by 11:15. Some sentence is there. What is the correspondence of this she? She relates to who? She relates to whom?
Uma.
Yes. How is that being identified? Only if your information doesn't vanish. You remember the sentence, the previously told sentence that Uma is handling a lecture. So this she corresponds to Uma, you will remember, and only then you will say that the she corresponds to Uma. But if it vanishes, I'm not explaining the word gradient, I'm literally explaining the word vanishing. You can relate that to gradient. Right? So this information vanishes, and this shouldn't happen for sequence handling because sequence is some order of words. And if it vanishes, then obviously this ANN cannot handle the sequences. So that is why we don't go in for ANNs. An exploding gradient is with respect to the weights. Right? So when your weights are exploding, I told you that you are having weight matrices in your artificial neural network. Right? If you have multiple layers in your neural networks and the weights are exploding like anything, in that case, what will happen? Again, this learning will stop. This will not allow your system to learn. Only when there is a gradient with proper values, then it will learn. When the gradient is shooting up, then also your system will not learn. Right, you can see some topics because if I get into vanishing and exploding gradient, that itself will take time. Right, so let me put it in that way. Exploding gradient in that way, like this she. If I mean, if there is one more sentence like, say, I'll take another girl's name like Anita is going to college. Say Rajeshwari College. Uma is handling lecture. She. Now she corresponds to Uma or Anita? right? If there is exploding gradient, then it will, this is a very literal example, this is will explode and it will say that this she corresponds to Anita, which is also wrong. If you don't remember the information, it is vanishing. If you remember unnecessary things, like if you're taking information from irrelevant sentences, then it becomes exploding gradient. Okay, so this problem is there in your artificial neural network. Literally, to understand the thing, I gave you a example, but you have to correlate that with gradients. Okay, so what is happening is that if I am saying that some information is passed from your input to your output, you measure your output. You measure your output. Say, for instance, if your sentence is like, this food is good. This food is good. I want to do sentiment classification. So this corresponds to the first feature, food corresponds to the second feature, is corresponds to the third feature, and good corresponds to the fourth feature. And what will be the training done? You know that this food is good is going to be a positive sentiment. And so, say I'm giving in terms of stars. So Y1 corresponds to 4 stars, Y2 corresponds to 3 stars, YK corresponds to 2 stars, and Y1 corresponds to 1 star. Now this statement is having positive sentiment, and so the output should be with 4 stars. But if you are getting an output with 2 stars, then this error should be propagated back, and again you should do some training, adjust the weights. That is what you can do, adjust the weight so that the output is going to be 4 stars. Okay, but here I am using artificial neural network. I'm not using recurrent neural network. So meaning that the next sentence should also have only 4 words. But in real time, is it possible? Is it possible to have equal sizes of inputs in natural language processing? It is not possible. The next sentence may be, this hotel is very good. Now I have 5. The input size is 5. So I cannot model using my neural network. So what should I do? Okay, so you have this thing. So when you have fixed size inputs and the whole input is available simultaneously, this another hack is that you should know the entire sentence. Right, then only you can find some output out of your artificial neural network. But that is not so in speech processing. I'm speaking. What would be my next word? I want to find out. Then I have only half of my inputs. I want the next word. Language translation. Right. It can be any size of input. I can give an English word which is 5 sentence. I can give an English word which may have English sentence which may have 7 words. So any video analysis, I can give a video with 10 frames. I can give a video with 20 frames. So the input size keeps on changing. Again, time series. I may be giving input for 5 days, whether I want to have the prediction for 6th day. I may give whether for 2 days, I want the prediction for the next day. So the input size keeps on changing, then RNN is used. So in real world, for natural language processing, it is always better to use a recurrent neural network, because in natural language processing, the input size keeps on changing. Is it okay? Is it okay, all of you? Any doubts? Okay, the features are same. Please understand, the features are same. I will come to that. Okay, I'll come to that. Okay, so now this is feed-forward neural network and this is recurrent neural network. What is this happening? I will elaborate soon. And we can see that we can apply recurrent neural network for time series data because it is having some order, text data, it is having some order, audio data, it is having some order. So these are all sequences, so I can apply recurrent neural network. So sequence models are the machine learning models that input or output sequences of data. Sequence data includes text streams, audio clips, video clips, and time series data, etc. And recurrent neural networks are the popular algorithm used for sequence models. Some applications of sequence models, I have already stated some application, but in spite of that, you can even see these applications. Speech recognition systems, wherein I give some speech, I want to generate a text out of that speech. So your speech itself is a sequence, and I give it to a neural network and gives me the words. Sentiment classification, as I already told you, you can see that, right? The words are different, right? So the input is of different sizes, and I want the output as rating 5-star, 4-star, whatever. Video activity recognition, I can give 5 frames, 4 frames. I want what activity is doing, whether he is running or whether he is standing, sitting. Okay, and please remember that your input should be a sequence. As I told you, in sentiment classification, I'm giving a sequence of words, but output is not a sequence. It's just giving me that it is 5-star or 4-star or 3-star. Output can be a sequence, output need not be a sequence. I'm giving, say, for instance, I'm giving the weather for 2 days. Today, 20th/4, the weather is 32 degree, and 21/4, the weather is 35 degree. I want the next 3 days prediction. The output is going to be a sequence. I want only 1 day prediction. That is going to be an individual value. Right? So there are different architectures that you have for your neural networks. I will come to that. Okay, so I'll have this first explained, and then I will tell you what is the difference between your artificial neural network and recurrent neural network architecture. So please understand that in your artificial neural network, how did you proceed? I had information this, I passed this information to the next level of neurons. I pass this information to the next level of neurons, and this information is passed to the next level of neurons. So this has access only to the previous level of neurons. This takes the input, right? And it processes the input and it takes the information to the next level. If you have 100 levels of neurons, the 98th level of neurons will have access to the 97th level of neurons alone. It will not have any information from your previous levels, the information that you have. Or instead, I can put it like this. This is going to be your artificial neural network. One layer of your recurrent neural network is equivalent to your artificial neural network. If you have one layer of, I'll show you this picture. This one layer of RNN, you call this as vanilla RNN. Vanilla RNN is equal to your artificial neural network. This is nothing but, I'll put it horizontally, I'll stack it horizontally. This is input, this is input, this is hidden layer, and this is output. Okay, so this is an artificial neural network. But when you are doing it with respect to time, layers this way, right, then it becomes a recurrent neural network. Right, so I may have one more hidden layer also here. This is one more hidden layer also. This is hidden layer 2, hidden layer 3. So understand that recurrent neural networks are connected artificial networks with respect to time. With respect to time, first level I have one, second level I have one, third level I have one, and what is happening in this time instance is passed to the next time instance. It is with respect to time that is happening. Okay, so if you have your thing, you can see that this is ht minus 1. This information, what I spoke at this time instance, is being passed to the next time instance here, and give the input What is the current input now? I have the previous information. Now I will predict the next level. Imagine this way. I have 32 degrees Celsius today. I have 34 degrees Celsius. So yesterday's temperature is 32 degree. Today's temperature is 34 degree. So there is some temporal relationship between this. There is a 2 degree difference between yesterday's temperature and today's temperature. So this temporal relationship is taken to the next level, and I will find out what will be the output at the next level, whether it is 36 degree or whether there is any relationship. How do I know it? This is like your simple sequence finding. We do it, right? When it is given 2, 4 and 6, what will be the next output? It is going to be 8. How do I identify? Because of the previous information that I have. There is some relationship between this and this. There is some relationship between this and this. So there should be some relationship between this and this. So it is not sufficient. I have only information 6. That is what is happening in artificial neural network. But here I have all information with respect to the previous time. And so I will be able to predict 8 correctly. But if I give only 6, then what will happen? It will not predict the right output because I don't have the information regarding the previous time instances. Is that clear, all of you? So this is what this same thing is represented here. So please, everywhere you will see this picture and you will get confused. What is this looping here? Why they are using looping is that they are saying that the same parameters are being used throughout your network. That is why they could actually wind it. This is a wind version of your recurrent neural. This is your unwind or unfolded version of your recurrent neural network. They are saying that the same V is used, the same W is being used, same U is being used for every time instances. They are just putting it in this form. If you unfold it, it will be like this. Okay. So now I'll give you an example. Maybe that will give you a clear picture. I think now you would understand, but still I will give you a clear picture of what is your recurrent neural network doing. So I will give the word for sentiment classification or something like that. I will give the word. So as I told you, you cannot give a word as such. You have to embed it. Because anything, a machine will understand only numbers. So first convert your words using some embedding. You can use one-hot encoding, or you can use word embedding systems. Okay, you encode it and give it to your hidden layer. Okay, so I am saying that I like this hotel. Okay, or this hotel is very good. So the first word is this. Okay, so now the hidden layer learns. It gives the features. Please understand that I am giving features as one-hot encoding. What is one-hot encoding? It has a vocabulary. So every, say I have 1,000 words in my vocabulary, I will take what is this? I will encode it in forms of ones and zeros. You can explore it because it will take some time. So I am giving it in form of a vector, say 0, 1, 0, 0, 0, 0, 0. I am representing this as one-hot encoding, and then I am giving it to my hidden layer. So these are all the features that I am giving to my hidden layer. Now this hidden layer will learn something from this, and it has some weights. Here also it has some weights, and here also it has some weights. But here I'm not going to get any output from a single word, so I'm not having any output here. Now it has learned something from this word, this. This information will pass. So this information will pass to the next layer, that is hidden layer 2. So hidden layer 2 will have information about this word, that is this, and this information is passed to the hidden layer 2. Now hidden layer 2 will have some weights associated with it. So you have some weights associated with it, and it will multiply this hidden layer information with this V matrix, and it will be passed to the hidden layer 2. And again, this will pass to the next layer. Now the input here is this hotel. Now the information is not just hotel, but it has information about the word this also. Okay, now again it moves to the next layer, which is hidden layer T. This 3 doesn't represent the hidden layer 3, this time instance. Please understand, I'm giving HL2 means time instance 2. HL3 means time instance 3. As I told you, this represents time. Please understand that. Don't get confused with the hidden layers that you are using in artificial neural network. This is with respect to time. Now I am telling this hotel is. Now this will have information not only about hotel, but also about the word this. Now I give information that very. Now this very will be encoded and given, and this hidden layer will learn some information from this word very, and it will pass this information to good also. Now I should have the output, whether this is positive sentiment or whether this is negative sentiment or whether it is neutral sentiment. Please understand the difference. In artificial neural network, you gave all the words at a time. So the relation between very and good will not be known in the artificial neural network. You understand? But here I'm giving at every point of time, and I know what happened previously. And so this processes the information in a better way, and I will be getting the sentiments positive, negative, and neutral. And also I can use this information to predict the next word also. So this is the idea behind your sequence modeling. So I am modeling the sequences with respect to time. And so therefore, when you are applying for a natural language processing task, you will be able to predict the sentiments correctly. And even you can predict the next word also. Okay, so you want to know the hotel is very dash. What will be the next word? I can predict it. Instead of predicting the sentence, I can predict the next word that will be uttered by the person. How can I do it? I can train with multiple sequences, and when the sequence comes, it learns from the trained sequences and it predicts what would be the next word. The same logic is there. It should not predict only with the knowledge of the previous word, but it should predict with the entire sentence. It should know the entire sentence and it should predict. So this is what is happening in recurrent neural network. So weights are shared. The same weight is used at every time instances. There are some problems. That is a problem of recurrent neural network, and we go in for LSTM. I cannot cover that LSTM in this lecture, but when you are sharing the weights, it doubles up. So there is a chance that when the weights are exploding, there will be a problem of exploding gradient, and also that you have multiple, you are remembering multiple previous instances, and thereby there is a problem of vanishing gradients also, and that is how that can be replaced or that can be addressed using your long short-term memory, which is again a recurrent neural network. Okay, but please understand how you model the sequences. If you know this, you can directly go into LSTM and find out what it is doing. So RNN takes the historical information for computation. Okay. So one-to-many architecture, many-to-one architecture, many-to-many architecture. So with this, I will wind up. What is one-to-many architecture? I give the image. It will provide caption. It will provide sequence of words explaining that image. That you can do it with recurrent neural network. Many-to-one architecture. I will give a set of words. It should tell me what is the sentiment. Many-to-many architecture. I will give a set of English words, translate it into a set of French words. That is many-to-many architectures. Right, and so that is what is shown in this picture. You understand? With respect to time, the connections are there. Okay, but there is a problem in RNN that it may remember only 2 or 3 time instances at the back. It may not remember long-term dependencies. It may not remember what is happening here. when it comes to this point, and this issue is being addressed using LSTM. Simple. RNN performs well compared to your artificial neural network. It remembers certain things, but the long-term relationships are being lost, and that can be learned when you use your LSTM. Okay, so these are all the applications of your recurrent neural network. Okay, so they are using the repetitive temporal relationship. That is what I told you, right? First came 2, next came 4, next came 6. What will be the next? There is some repetition. Input size is variable. That is an important feature of RNN. The input size need not be fixed. And the weight matrix does not change with time. Whatever weight matrix I'm using in time t1, I'm using in time t2. That is a very big advantage of recurrent neural. Right? So this is some GIF thing that I'm showing. You can see that when it is handling time, it has information about what, that is represented using black. And when it is handling is, it has information about time and what. And when it is handling it has information about what time and is. And finally, it can predict the next word based on this information. And this is how the sequential information is being handled using your recurrent neural network. So the advantage again is parameter sharing. The same parameters are being used, but in your artificial neural network, at every layer, we'll be using different weight matrices. And so there will be like too many parameters that you have to train, but here the parameters are less, and so it decreases the computational cost. Okay. And the challenges, as I told you, there is a problem of vanishing gradient and exploding gradient. The long-term dependencies, that what? If I'm having this output, it doesn't remember this. So for this, you can use your long short-term memory, which I cannot cover it in this session. And so I hope you understand the difference. You can see that. You can even forget about CNN. So RNN, recurrent connections are there, parameter sharing are there, and vanishing exploding gradient are there. To overcome that, you can go in for LSTM. But one thing is that it will handle sequence data, whereas it can handle only tabular data. Tabular data in the sense fixed size of data. Okay. So with this, I'll stop. So hope I satisfied some of your requirements. So any questions, I'll be happy to answer.
Ma'am, can you please tell what is a recursive recurrent neural network, ma'am?
Yes. Recursive neural network is somewhat different from your recurrent neural network, ma'am. In recurrent neural network, we have a linear way of modeling your sequence. But in your recursive neural network, it will be like a tree child. It will be form of a tree. And you will be using something like topological ordering. What comes next? What comes next? So that parent-child relationship will be there in your recursive neural network, and they are also used for sequence modeling. Here it is linear, right? Your recurrent neural network goes from left to right, but wherein there you will be having a tree form. This comes next to this comes, there will be a parent-child relationship.
Thank you, ma'am.
Any other question? Hope it was informative. Yes, sir. Durai Murugan and John Vasikaran have raised their hands. So you can ask your questions. I don't know if they have raised their hands. Any doubts? So I've given one part of your sequence modeling for sentiment classification. You can try prediction of words. You can even try music generation. Like I give the genre, like I am giving, like I want a melody type of music generation. If you give the genre, it will generate the audio. So even videos, I can give the frames, I can do activity recognition. So many applications are there for your sequence modeling. And one such application is for natural language processing. So you can use it for natural language processing as well. Okay, any doubts? Okay, thank you then. Thank you for sparing your time and listening to my lecture. So if any queries are there, you can very well contact me. You can find my ID in University, Pondicherry University website, and you can ask your questions. So thank you, organizers, and Dr. Jayashree Madam and my own student, Mr. Manigandan, for providing me this opportunity to deliver a lecture on sequence modeling for natural language processing. Thank you so much.
Ma'am, thank you
Thank you,
so
ma'am.
much, ma'am. It was really an extraordinary session, ma'am. I think you are a legend. You are such a great, talented person in deep learning, ma'am. I mean, I don't have a better place than this to say. Thank you so much
Thank you,
for
Manigandan. I'm not that great and all, but I
giving us
keep
time in a
learning.
busy schedule. Thank you so much, ma'am. I
Okay.
really am saying in today I learned so many unlearned things from you, ma'am. It was really a absolute pleasure.
Thank you, Manigandan. I always remember you for your questions, and always he'll be very interactive in his classes. He'll be asking questions, and that actually improves the faculty also. So, in that way, I think some of you interacted. Not many interaction were there. I would have been happy if more queries were there. But I hope I satisfied your requirements. That may be the reason for not having any questions, or I should take that in a positive way only. So that is how we have been taking
We
classes for the.
understood. That is what we didn't ask
Yes.
that much questions here.
Thank you, Manikandan. And please keep learning. This machine learning
Yes.
and deep learning field is like it's exploding actually. So many new techniques and so many new fields are emerging. So please keep learning. Don't just get satisfied with the lectures that are being given. Attending some webinars, you keep learning. Attend some courses in Coursera, NPTEL, Udemy, and then enrich your knowledge. And that will actually help you in getting more research publications and more research works. So in that way, I always have pleasure in learning. So please do that, and good luck to all the participants. Thank you.
Thank you, ma'am.
Thank you. Ma'am, can I break?
Yes, ma'am. Yes, ma'am. You can. Thank you, ma'am.
Okay. Thank you.